Friends, in this really physics related video, and in this video we'll learn how g or weight changes with place and time. So why did we compare g and weight? Because we know that weight w is equals to m times g, and as m is a constant, the g only depends on the gravitational acceleration or the small g, and that's why if the g changes, the weight also changes with place and time. And this you have learned in our previous video. So let's continue on our today's lesson. So this is the first cause why g or weight changes with place and time. So we know that the earth rotates around the sun, and that motion is called annual motion. But the earth also rotates around its own axis, which is called the diurnal motion. And if you take this red line as the earth axis, the earth will rotate around its own axis like this line. This path is showing the rotation of earth around its own axis, which is called the diurnal motion. And as this happens, if this is the earth and this is the center of the earth, this region will be called the polar region, and this region or these regions will be called the nocturnal region. And as the diurnal motion happens, the g or the weight becomes less from this region to this region. When you are on the polar region, the g is greater than this region, and if you come from this region to this region, or from the polar region to this equinoctial region, so the g will become less. Suppose the weight of an object is 100 Newton in the polar region, and when you will come to the equinoctial region, the weight will become less. This will be around 99 point something Newton. That means for the diurnal motion of earth, the g or weight changes or becomes different in different areas or regions on the earth, and that's the first cause why g or weight changes with place and time. So this is the second cause, and here we see the earth. So here you will see a red line here and a green line here. So the green line seems to be larger than the red line, and yes, this is because the earth is not a fully round circle object, right? And as this is the distance from these regions and these regions are greater than the distance of these regions and these regions, and these regions are called equinoctial regions, and you learned this in the previous course, and these regions are called the polar regions. You also learned this in the previous course. So why are we talking about this? Because we know that g is g times m by r square, divided by r square, and we know that these numbers are constant, and that's why the g only depends on r, or the radius, or the distance from the center of earth. So when the r will be greater, the g will be less or lesser, and when the r will be less, the g will be greater. Or when the radius or the distance of the object from the center of earth will be lesser, the g, or the gravitational acceleration, will be greater. So if this is the center of the earth, you understand that the distance from this region to the center of earth is less than the distance of this region to the center of earth. And this is a big problem, and that's why when you are here, your weight will be greater, and when you are here, your weight will be lesser. And you understand why this happens? Because if this is R1 and this is R2, the R1 is less or smaller than R2, and when R2 is larger, the G is smaller, and when the R1 is lesser or smaller, the G will be greater. And this is the second and the biggest cause why G, or weight, changes in defined regions of Earth. So what will happen if something is there? You know that always depends that how far is the object from the center of Earth. If the center of Earth and the object has larger difference or distance, the g, or the gravitational acceleration, or the weight will be less. And if the distance of center of earth and the object is smaller or less, the gravitational acceleration or the weight will be greater. So let's continue to the next cause. So this is the third cause and the final cause. So here you see that this is the earth, and some objects are placed in different places. You see? Why did you do this? Carefully look at them. The yellow, we can call it Y, is on the ground of earth, right? So this is blue, so what we can recognize the distance of the object in the center of earth as b. That is the first letter of the word blue. And here the red object is not on the ground. This is looks like this is in the quite nearer or quite close to the center of earth. So let's call this red object R, the radius from the center of earth and the red object, let's call it R2. And the green object, this is not on the ground of R2. This seems to be have a greater distance from the center of earth than the others. So let's call it the green object or G, and the distance from the center of earth to the object is also G. Look carefully, these are not the gravitational acceleration, these are some signs. So what you see here, let's remember, this is G. The gravitational acceleration is g m by r square, right? Divided by r squared. So when the radius is smaller, the gravitational acceleration or the weight is greater. And when here we have seen that the distance of the center and the object is greater than the red object, that means the weight that is the red object have a weight, and this is greater than the weight of this object because the yellow object is far away than the red object from the center of Earth. And as this happens, the radius or the distance from the center of Earth to the yellow object is greater than the distance of the red object at the center of Earth. That means we have learned it in the previous course. So we know that the GR weight will be less than the red object, and this is also right to this object or the green object. Why? Because the green object is too far away, or it is have a larger distance from the center of Earth. Even this is larger than the yellow object, and with your basic knowledge you know that the distance, or we called it G here, is greater than this and this. So the gravitational acceleration and weight will be less. That means which have the greater weight or gravitational acceleration. Try to recognize. Yes, you're right. The red object has the most weight, or it seems to be heavier than the other objects and has a greater gravitational acceleration than this object and this object. And the yellow object has a greater gravitational acceleration and weight than the green object, and the green object has the smallest or the most less weight and gravitational acceleration than the other objects. And this is the final cause of why GR weight changes with place and time. You know, if the object is if the weight is placed near at somewhere that is near the center of Earth, the or gravitational acceleration and weight will be greater, and when this is placed far away, the gravitational acceleration or weight will be lesser. And this is very basic concepts. So I hope you have understood the concepts clearly, and if yes, please subscribe this channel. You can use this watermark here. And thanks for watching again. Please like, share, and put a comment if you like this video and if you have any question. Thanks for watching again.